Hello, folks. Welcome back to Merrillmath. I'm Mr. Merrill. Today we're talking more about FOIL. This time it's in quotes. I've got some trickier examples here. The reason it's in quotes is because the examples I have more than two terms for the binomials. Actually, this one's a trinomial. So you talk about first, outer, inner. There's two inner terms here. So it's not exactly FOIL, but it follows the same format. Now I'm going to be using expansion boxes for this one. So we have a trinomial here. We're going to multiply it by this binomial. And like I said in the previous video, we're talking about the distributive property, but we're doing it 3 times. So the x squared, we're going to multiply it by those. The 3x, we're multiplying it by the 8x and the 6. And the 2, we're multiplying by the 8x and the 6 as well. So I need to draw out my expansion box here. Now it's going to be a 3 by 2 because I have 3 terms here, 2 terms there. So let's make this, it's not perfect, but our first term here, we have x squared, we have 3x, and we have a 2. Now these are all plus. We can put the signs in there, but they're positive, so it doesn't really matter. And here we have an 8x, and a plus 6. So what we're going to do is we're going to multiply these out. So where they intersect, we're going to have 8x times x squared. That's an 8x squared. That's an 8x cubed. Okay, so I got to do my counting here. X squared times 6, that's going to be a 6x squared. 3x times 8x, 8 times 3 is 24. X times x is x squared. Down here we have 3x times 6. That's going to be 18. 6 times 3 is 18. We've just got an x that comes along for the ride. 8x times 2 is going to be 16x. And 6 times 2, our last term, is just 12. Okay, one thing that's nice about the expansion boxes that we can see from this example is our like terms are on these diagonals. So this 18x and this 16x, those are like terms. So we can just see those visually, and it's very easy to combine them. If we did it the normal way, it would be a lot messier. Okay, so we've got our 8x cubed. And we have a 6x squared plus a 24x that gives us 6 plus 24 is 30 x squared. Now, when we write these out, I suppose we could say the correct way to do it is to look at our exponents. The biggest exponents go first, and then we kind of count down from there. So our biggest exponent is a 3, so that one goes first. And then the 2, then the 1. We typically don't write the 1, but so our next term, 18 plus 16. Well, let's see, 16 plus 16 is 32, plus 2 more, that's going to be 34, x, and then we have this 12 that comes along for the ride. So we have 8x cubed plus 30x squared plus 34x plus 12, and that's our answer. So let's take a look at another example here. Kind of one of these trickier ones that involves a trinomial instead of a binomial. So this one has more negative signs involved, and that's why I selected this one. So for our second example, again, we have to draw a expansion box. And you don't have to use these, but I find that they help keep me organized. So, so we have 2x squared minus 3x minus 4. Goes across the top, and then an x plus 5 on the side here. So we're going to do our multiplication. Let's see here. So we have 2x squared times x. So it gives us 2x to the third. We have x times a minus 3x. That's going to be minus 3x squared. And a negative 4 times x. That's minus 4x. Down here, we're going to say 5 times 2, that's 10. and then our x squared comes along for the ride. 5 times the negative 3, it's going to be a minus 15, and then our x comes along. And then 5 times minus 4, that gives us minus 20. Now notice that our like terms, again, are on these diagonals. So we can combine those. Let's see here. So we're going to end up with 2x cubed. We have 10x squared minus 3x squared. So we could say 10, if we have 10 apples and we subtract 3 apples, right? Like it's going to give us 7 apples. But in this case, our apples are x squareds. And here we have negative 15 bananas, and we're subtracting 4 bananas. That gives us negative 19 bananas, but in this case our bananas are x's. And our negative 20 comes along for the ride. So these are a couple of trickier examples that you might see with FOIL, and kind of the advantages to using expansion boxes.